What we're building up to in Chapter 5 is various relationships within triangles. So we talked about mid-segments and the special properties that they have. We're going to talk about perpendicular bisectors and some of the properties that they have, and also angle bisectors and some of the properties they have. So before we can get into some of the special properties about perpendicular bisectors, we need to define the word equidistant. What do you think the word equidistant means? Same distance, equal distance, absolutely. So the perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if we have line segment AB perpendicular to line segment CD, with AC congruent to CB, that would be a perpendicular bisector because it's perpendicular and it cuts that segment into two equal parts. So if we have that situation, then we know that any point on this bisector here, on this segment CD, will be equidistant from A and B. So DA has to be congruent to DB. And that will be true of any point, whether it's, if we drew this as a line, whether it's down here, those two would be equal, or those two, or those two. We could do it anywhere, any point, and connect to the endpoints, and those two will be congruent to each other. So this has to be congruent to this. Okay. Converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. So if what we are given is a triangle with like AC congruent to CB, for example, if we draw a line down from C to AB, it will be perpendicular. And it will be in the middle of AB. So it'll be perpendicular and AD will be congruent to DB. Okay. Looking at an example, we're looking for the length of line segment AB. So if you look at the triangle that they gave us here, the things that they are telling us have to be true is that AD is congruent to DC, and that we have a right angle at angle D. So that means that BD is the perpendicular bisector of AC. So that means that AB has to be congruent to BC. So the way that we are going to solve this problem is set 4x equal to 6x minus 10. To solve that equation, I would subtract 6x from each side. So negative 2x equals negative 10. Divide by negative 2, x equals 5. Now, the question is, what is the length of line segment AB? So I have to look at what that is. Plug in my x equals 5. So my answer would be 20.